In this segment of the lecture, I'll discuss a couple other AWS services which we commonly use, starting with the Simple Email Service, or SES. Simple Email Service is a managed email relay service provided by AWS. Essentially, it allows you to send outgoing email messages from your applications running within AWS. Now, you can't just set up your own email server within your AWS account. AWS sort of explicitly blocks the standard SMTP email traffic. And that's because AWS is trying to prevent people from setting up mail spamming relays within their accounts. You know, the thinking is that somebody could, steal a credit card and use that credit card information to create an AWS account, and then they will launch a mail relay server that will send out billions of email messages to people all over the world, and that's really annoying. So AWS tries to prevent its customers from setting up their own mail relay services. So in lieu of that, AWS offers an email relay service called SES. The messages that are relayed through SES are sent via the standard SMTP protocol, which is the protocol that all mail servers use across the internet to send messages and route messages between mail servers. You are essentially billed based upon the block of messages that you send on a monthly basis, and you can send up to 62,000 email messages free within the free tier, but then you will pay for the number of messages that you send above and beyond that particular level. And when you first set up the SES service, AWS will limit the number of messages that you can send per day. So they kind of throttle you at first, but you can then, over time, you can request a limit increase so that you can send more and more messages. AWS is just trying to be very, very cautious and make sure that you aren't sending out spam messages to not only your customers, but to potentially prospective customers. The next service I want to cover is the Route53 service. The Route53 service is a managed domain name hosting and registration service. This is where you can register your own domain names. These could be, .com sort of domain names. You register a domain name, and then you create a set of host records for that domain name. And the host records describe, essentially describe how to map that domain name record to an IP address. You might be wondering, where does this Route53 name come from? Well, it's actually based on the famous Route 66 highway that crossed America in the 20th century. And in this case, it's called Route 53 because 53 is the standard port number for the DNS service. Well, you've probably heard of DNS before. And DNS is a critical part of the internet, and it's a critical part of your experience when working on the internet. If you're working with a web browser, then you are constantly using the DNS service to map human-readable domain names to IP addresses. Remember, at the end of the day, your computer, when it's communicating with a website somewhere on the internet, your computer isn't talking to a domain name. It's not talking to www.domain.com. It's talking to an IP address. So there has to be a mechanism to translate the domain name, the human readable website address, into an actual IP address. And that's what the DNS service provides. The DNS service is really critical. If your web browser, if your workstation wasn't able to connect to a DNS service, then essentially it would have a really hard time finding the computers that it needs to communicate with when you're browsing websites. Effectively, it would shut down your ability to browse websites because you could no longer map the DNS names into IP addresses. How does DNS work? I know many of you out there probably already know how DNS works, but for those of you who are unfamiliar with the service, it's actually quite a sophisticated service in some ways. You can think of it as sort of like a massively distributed database in a way, and it's sort of like this big database tree structure. Essentially what happens is on the left-hand side, you've got your workstation, your laptop, or it could be even your cell phone or your tablet device. You're using some device to access the internet. That's your client workstation. And you make a request to access a website. Well, you're typing in www.yourcompany.com as the website address. And what will happen in the background is there's a DNS client on your workstation which will go out and try to retrieve the IP address associated with that particular website. And it does that by first communicating with the default DNS server that's configured in the network settings on your workstation. And that default DNS server is generally provided by your internet service provider. So your workstation will communicate with the internet service provider's DNS server and ask that DNS server if it knows the IP address for www.yourcompany.com. And the internet service provider's DNS server says, no, I don't know the IP address, but I know who knows. And so it will reach out to a root DNS server on the internet and ask the root DNS server if it knows the IP address for www.yourcompany.com. And the root DNS server says, no, I don't know the IP address, but I know somebody who might know what that IP address is. And it will redirect you to a top-level DNS server that's responsible for the .com domain names. And so your ISP's DNS server then reaches out to the top-level DNS server and says, hey, do you know the IP address for www.yourcompany.com? And that server says, no, but I know somebody who does know the IP address. And it redirects your internet service provider's DNS server to the DNS server which hosts the registration information for yourcompany.com's domain. And that server is able to provide a mapping. It's able to map the www host to a particular IP address. And it provides that IP address back to your internet service provider's DNS server and then ultimately back to your workstation. So now your web browser is able to connect directly to the IP address in the web server that is hosting the www.yourcompany.com website. Well, it seems like there's a lot of stuff happening in the background, and there is. I mean, it might take several requests running in the background before your workstation is able to get the actual IP address for that remote server. Now, once your internet service provider's DNS server retrieves that IP address, it will then cache it for a period of time. So if your server asks again, your workstation asks the ISP again for that IP address, then it doesn't have to go out and talk to all these servers to find the IP address. It can just provide it right away because it's been cached in memory. And your local workstation will also cache that IP address for a period of time as well. But there's all kinds of processing going on in the background every time you make a request to a website. And of course, this happens very, very quickly in most cases. And some cases, when you make a request to get access a website, if it takes a little longer, well, some of that could be due to the fact that it's actually trying to look up the IP address using DNS. The Route53 service can act as both a domain registrar and a name server. As a domain registrar, that means you can actually buy domain names directly from Amazon using the Route53 service. You buy a domain name and you pay for the ownership of that domain name on an annual basis. And the cost of the domain name can depend on the top level domain that you use, like if it's .com or .net or .info. I mean, there's like hundreds of top level domains that are available today, and they have different sort of levels of pricing. Route53 can also serve as a name server, and what that means is that it can provide all of the authoritative records for a domain name. These are the records that are mapping a particular host name to a specific IP address. And when you set up a record, an authoritative record for a domain, there are a number of different record types that you can use. Everything from the start of authority records, which are providing sort of metadata associated with the domain. You can set up address records. Those are really common, where you can map a specific host name like www to an IP address. You can use CNAME records. These are sort of canonical name records. This is a way to map a host name to a fully qualified domain name. So instead of mapping a host name to an IP address, you can map a host name to a fully qualified domain name. And then finally, you can set up alias records, which are sort of like CNAMEs, but in terms of the destination, you can use dynamic AWS records like Elastic Load Balancer endpoints, which is a really handy feature of Route53. When you set up when you host a domain using the name service capability in Route53, you can configure Route53 routing policies. And routing policies are used to essentially distribute traffic across multiple regions. And so this is the problem that Route53 is helping us solve. You're familiar already with Elastic Load Balancers. Elastic Load Balancers will run within, are configured to run within a specific VPC within a specific region. And the load balancer will distribute incoming requests across a set of EC2 instances running within that particular VPC. Those EC2 instances could be set up in multiple availability zones. But the question is, how do we distribute requests across multiple regions? We can use Elastic Load Balancers to distribute requests within a particular region. But let's say we want to design our platform so that it is hosted in 2 different regions. How can we distribute traffic, incoming traffic from our customers, across multiple regions? Well, we can do that using Route53 routing policies. And there are a handful of different routing policies which are available. The first is what we call the simple routing policy. This is the default policy, which simply maps a DNS request to one or more IP addresses. So So it's very simple. www equals a specific IP address. It's mapping a host name to an IP address. We can use a multi-value answer routing policy, which is the same as the simple policy, except Route53 will actually perform some health checks. So under a simple policy, we could map a host record like www. We could map it to 2 IP addresses, and those 2 IP addresses could be the addresses of our public web servers. And what will happen is that every time somebody makes a request for www.yourdomain.com, the Route53 service will respond back with a random IP address. So it'll pick one of those 2 IP addresses and just randomly provide either one. And it does that irrespective of the actual health of the web servers. The Route53 service, and if it's using the simple policy, it's just providing an IP address. If you specify multi-value answer as the routing policy, Route53 will perform a health check on your EC2 instance, and it will only respond back with the EC2 instance's IP address if it's healthy. If it's not, then it will actually remove that IP address from the list of potential IP addresses that it will return. The weighted routing policy allows you to use Route53 to distribute traffic over multiple regions based upon some sort of weighting that you associate with each region. For example, you might have your application platform running in US East 1 and in US West 1. But maybe you want 85% of your traffic, of your customer traffic, to go to the US East 1 region, and 15% of your traffic to go to US West 1. Well, you can do that using a weighted routing policy. The latency routing policy allows you to distribute traffic to the lowest latency region from the perspective of the customer. So, for example, US-based customers might be directed to a US East 1 region, and European customers would be directed to the European West 1 region. So in this case, you might have an application platform that is running in multiple regions. One region is in the US, one is in Europe, and you want the US-based customers to be directed to the platform that's running in US East 1, and you want the European customers directed to the European region. Why would you want to do that? Well, you might have compliancy requirements. In the European region, you have things like the GDPR that that are sort of providing for data privacy, and your company, if it's operating in Europe, must comply with those data privacy requirements. And so you would want to make sure that your European customers aren't directed to the platform that is deployed here in America. The failover routing policy allows you to basically specify a primary region that your customers should be directed to. And Route53 will monitor the status of your services running in that primary region. And if it senses a failure in those services, then it will automatically redirect customers to a secondary region. They will fail over to that secondary region. And this sort of policy is primarily used for disaster recovery purposes. It protects you against the failure of an entire region. Maybe you don't want to run your platform in 2 different regions simultaneously. You want your platform running in a single region like US East 1, but if if that region were to fail, then you could reroute all of your traffic to the US West 1 region as a failover. The geolocation routing policy will distribute traffic and route traffic to a specific region based on the physical location of a user. So this is a little bit different than the latency. The latency is based upon sort of like what's the fastest region that a customer could access. This is based on geolocation. So where is the user located physically? And we can specify where where customers should be directed to based upon their physical location. And then finally, the geo-proximity routing policy is based on traffic flow. So it's based both on the physical location of the user and the location of resources. So you can actually set specific geographic regions around the world, and you can sort of map those to particular AWS regions. Here's an example of a disaster recovery architecture that you could create using Route 53. So we have, in this case, we have our platform that is configured in two different regions, US East, North Virginia, and US West in North California, US North 1, or US West 1. And in this case, both regions have an elastic load balancer. The elastic load balancer is going to take an incoming request and distribute that request across a set of web servers. And those web servers are communicating with a database server. And this is an active passive sort of configuration. All of our customers are actively going to US East 1. And the data in our database is being mirrored. It's being replicated to a secondary database located in US West 1. Now, if there were a failover event, if the Route 53 service were to detect a health check failure in our primary region, then it would automatically redirect traffic over to the second elastic load balancer located in US West 1. And that load balancer can distribute traffic across a set of web servers. And those web servers are talking to the secondary database where our data has been replicated. So the DNS service, the way it's redirecting this traffic is just simply by when clients are requesting the address for www.yourcompany.com, the DNS server, the DNS service, normally is responding with the location of the load balancer in US East 1. But if this region were to fail, then the DNS service will begin responding with the location of the elastic load balancer in US West 1. So it's just simply providing clients with a different IP address. It's as simple as that. But this is a very effective way to essentially support an application deployment across multiple regions and set up a disaster recovery sort of architecture.